Okay, picture this. Somewhere out there, in a massive, humming data center right this very second, a machine is doing something no computer has ever done before. And no, it's not writing a marketing email or rendering the latest video game. It is actually simulating complex molecules using math that, honestly, until very recently, only existed in advanced physics textbooks. Welcome to 2026. Computing isn't just getting a little bit faster anymore, it is fundamentally changing what a computer even is. So we're cutting through all the hype today in this explainer to look at the invisible revolution that is happening right beneath our keyboards. Section 1. AI as the new foundation, the shift in enterprise architecture. For the longest time, right, AI was basically just this extra thing sitting on top of our IT systems. A chatbot bolted onto a customer service website or a neat little plugin inside an app. Well, that era is officially over. The actual plumbing that runs our world, the banks, the hospitals, the global logistics pipelines, it's being completely rebuilt from the ground up. AI is no longer just a cool add-on. It is the core layer. It's the absolute foundation. We aren't really sitting around in meetings anymore asking, hey, should we use AI for this? Instead, the entire system just assumes AI is already there, working in the background. Now, because of this, AI coding tools have quietly become a massive disruptive force. I mean, you can write and ship complex software, websites, whole games dramatically faster than you could even just 2 years ago. But here's the catch, and it's a big one. Speed does not equal correctness. These tools are unbelievably powerful, sure, but they still make mistakes. And worse, they make those mistakes with absolute confidence. That is exactly why the crucial professional habit today isn't to just blindly trust the machine. It's to verify what the AI gives you. The tools got faster? Absolutely. But human discipline, rigorous testing, and double-checking, they are literally more vital than ever. Moving right along to Section 2, quantum computing gets real, moving out of the lab. So traditional computers, the ones you and I use every day, they store information strictly as bits. Think of a traditional bit like a coin sitting flat on a table. It's either heads or tails, a 0 or a 1. Simple, right? But quantum computers, they use qubits. And a qubit is more like that coin spinning on the table. It's existing in multiple states all at once until you finally stop it. And this wild, abstract physics allows quantum machines to take on incredibly complex problems that would take a classical supercomputer thousands of years to solve and totally crack them in mere minutes. And this immense leap in power, it's no longer just confined to theoretical academic papers. It is actively touching our world right now. We are seeing it accelerate scientific discovery, push forward insane medical breakthroughs, advance materials science, and solve these massive optimization problems that were previously just way too heavy to process. But of course, there is a flip side to all this power. Because while it's unlocking the future, it is simultaneously creating a massive vulnerability that the entire IT industry is currently racing to solve.
Which brings us to Section 3, the post-quantum security race, defending the future.
Okay, here is the really uncomfortable truth about 2026. The encryption that is currently protecting your bank accounts, your private medical records, your company's sensitive data, all of it could eventually be shattered by a sufficiently powerful quantum computer. Now, the machines aren't fully there just yet, but the threat is incredibly immediate. Why? Because attackers are out there currently stealing encrypted data simply to hoard it. They know they can't read it today, but they are patiently waiting for the technology to catch up so they can crack it tomorrow. Security teams call this chilling strategy Harvest Now, Decrypt Later. And it's exactly why you're seeing massive, urgent investment right now into post-quantum cryptography. These are entirely new standards designed to resist attacks before the quantum machines are fully weaponized. Because these attackers are getting so much smarter, the whole industry's defense playbook has evolved into 3 core pillars. First up, AI-powered threat detection. This is AI spotting weird network anomalies way faster than a human security guard ever could. Second, zero-trust security models. Basically, this means absolutely nothing. No user, no device, no matter who they say they are, is automatically trusted just because they happen to be inside the network walls. And third, ironically enough, there's a massive renewed push for basic digital hygiene. Because even in an era of quantum threats and advanced AI, a shockingly huge share of data breaches still happen simply because someone clicked a bad link. It just proves that security has got to be built in from the absolute start, not just tacked on at the end as an afterthought. All right, Section 4. Cloud 3.0 and tech sovereignty, the intelligent infrastructure. Remember when the cloud just meant, backing up your photos or storing files somewhere other than your local hard drive? Yeah, that is officially ancient news. We are leaping from the traditional cloud straight into Cloud 3.0. We aren't just blindly hosting applications anymore. Cloud 3.0 actively powers intelligent operations. So instead of just sitting there waiting to respond to a user's request, these enterprise systems actually anticipate what you need and automate the decisions for you. Rather than just centralizing everything in one big data center, the new cloud adapts in real time. Honestly, it's like a living, breathing digital nervous system. And right alongside this explosion of cloud intelligence is the critical rise of tech sovereignty. The world is getting complicated, and organizations, really entire countries, are demanding localized control over their own data. They simply don't want to be entirely reliant on just a handful of massive global providers anymore. The whole mindset has shifted from just put it all on the global cloud somewhere to we need to know exactly where our physical infrastructure actually is, and more importantly, who controls the switch. Section 5. The hardware underneath it all, powering the invisible revolution. Because hey, none of this, not the foundational AI, not the quantum leaps, not that highly intelligent cloud, none of it actually works without physical hardware. The physical layer of the data center is being quietly but radically reinvented as we speak. And a huge part of that puzzle is managing power. Take batteries, for example. We are actively shifting away from scarce materials like lithium and moving towards sodium-ion batteries. Yes, you heard that right. Basically, the exact same sodium found in your kitchen table salt is emerging as a drastically cheaper, safer, and incredibly abundant alternative to back up these massive, rapidly expanding data centers. And speaking of power, AI and quantum systems do not run on good vibes. They run on electricity, and an enormous amount of it. To feed these incredibly power-hungry systems, nuclear energy is actually having a major resurgence. It provides this steady, reliable, completely emissions-free backbone that modern computing desperately requires so it can scale up without completely breaking the local power grid. Finally, Section 6. What this means for you, navigating the converging forces. So we have covered a whole lot of ground today, but how do all these massive overlapping shifts actually impact your day-to-day professional reality? Well, if you work in software, AI tools are going to write the bulk of your code, which makes your ability to rigorously review and verify that code your single most valuable skill. If you're in security, concepts like post-quantum cryptography and zero trust aren't just trendy buzzwords to put on a resume anymore. They are the absolute baseline expectations of your job. In infrastructure, your whole focus shifts to building intelligent and sovereign systems. And for everyday users, your tools are just vastly more capable, anticipating your needs completely seamlessly. Look, we are not at the end of any of these stories. We are right in the messy, exciting middle of all of them happening at the exact same time. As computing in 2026 becomes the seamless convergence of foundational AI, insane quantum power, and completely reinvented hardware, it leaves us with one really powerful realization. The most profound shift we're facing isn't some flashy new gadget you hold in your hand. It's that the greatest, most advanced technology becomes entirely invisible. It just works, quietly running the entire world in the background. So the real question you have to ask yourself today is this: are you ready for the technology you stop noticing? If this explainer helps you find the real signal in all that noise, make sure to subscribe to Vimas Tech for more deep dives into exactly where our world is heading next.